So now let us look at some of the standard formulas which will be useful in solving algebraic limits. There is limits involving only polynomials or square roots of polynomials. So first you have the first set involving integration of 1 by some sort of quadratic expression. 1 by a square minus x square, and 1 by x square minus a square, and 1 by x square plus a square dx. So integration of 1 by a square minus x square is 1 by 2a log of a plus x by a minus x plus c. And x square minus a square is 1 by 2a log x minus a by x plus a. And 1 by x square plus a square's integration is 1 by a tan inverse of x by a. So these are the first three integrals which will be useful in integrating 1 by quadratic type of problems. As you can see, this is a quadratic expression. So 1 by quadratics can be solved using these formulas. And next you have the formulas involving 1 by root of some sort of quadratic form. So 1 by root of a square minus x square dx is sin inverse x by a. 1 by root of x square minus a square dx is log of x plus root of x square minus a square. 1 by root of x square plus a square is log of x plus root of x square plus a square. So the formulas are quite simple. And if you have directly root of quadratic in the numerator, so root of a square minus x square is x by 2 into root of a square minus x square plus a square by 2 sin inverse of x by a. And root of x square minus a square is x by 2 root of x square minus a square minus a square by 2 log of x plus root of x square plus x square minus a square. And root of x square plus a square is x by 2 root of x square plus a square by 2 log of x plus root of x square plus a square. So these three formulas looks slightly lengthy, but these formulas are very closely related to these formulas if you see. So the first three formulas, if there are no square roots, you need to remember that you get a 1 by a outside. The first two problems you get 1 by 2a outside. 1 by x square plus a square is very straightforward. You know already that this is something related to tan inverse, because 1 by 1 plus x square's integration is tan inverse x. So 1 by x square plus a square's integration is 1 by a tan inverse of x by a. So this can be separately remembered, and these two you can remember as 1 by 2a, 1 by 2a is common. Log of, if the constant is positive, you get positive symbol in the numerator. If the constant is negative, you get a negative symbol in the numerator. That's how you remember this. And instead of 1 by root of a square minus x square. So in terms of root of a square minus x square, we know that root of 1 minus x square is sin inverse of x by a. So root of a square minus x square is related to sin inverse, and the remaining two are related to log. So log of simply x plus whatever is there here. Log of x plus whatever is there here. And if you go for the third formulas, if root of x square minus a square or a square plus x square or a square minus x square is in the numerator, so what you get is x by 2 times whatever is given is common in all the three. X by 2 times whatever is given. And afterwards, look at the sign of the constant. If the sign of constant is positive, you get plus. If the sign of constant is negative, you get a minus. And a square by 2 is same. And a square by 2 has to be multiplied with the corresponding formula of 1 by root. So root of a square minus x square, you have the corresponding formula 1 by root of a square minus x square. Root of x square minus a square, you have the corresponding formula. Here you have the corresponding formula. So these are the three sets which will be very useful in solving many algebraic integrals. So now before going into the questions, let us see how these formulas have come. So I'm not going to derive all of them. I'm going to derive a few of these such that you get some idea how these are getting derived.